All right, well, welcome everyone. Thanks for coming. We're really happy to see faces. I'm delighted to introduce Drs. Bridget Cotti-Rausch and Doug Bell, although I've been told to call them Doug and Bridget. So Doug and Bridget are joining us from Washington, D.C. Bridget is an awards program analyst at the Department of Treasury, and Doug is a management and program analyst at NOAA, National Oceanic and Atmospheric Administration. Because you probably wonder if I didn't actually acknowledge it, yes, these guys are family. So I'm not going to go into details about their educational backgrounds because I'm sure they're including that in their presentation. But I do get to say that they're like kind and smart people, and I'm glad that they're in the government. With any potential to influence the government, I'm glad these two have it. So please join me in welcoming and thanking Doug and Bridget in advance for coming. We're really looking forward to learning from y'all. Thanks.
Awesome. Thanks, Margaret. And if none of you guys believe me, believe Margaret, just realized this behind me. Can we show that?
Family photo.
Family photo. Do you see Margaret in the hat?
That was Sleeping
That's
Bear.
an old picture. Yeah.
Yeah, no Jonas.
It is. Well, thanks for inviting Bridget and I. We were requested to give a talk about our fellowship experience to our graduate school, University of South Carolina, last year. So we put together a presentation that's, part explaining, policy jobs in the government and science, our own specific experience, and they were kind of tailored to more marine science disciplines. But we've hopefully expanded this presentation a little bit. And what we hope to just kind of give an example of is how to apply your STEM degree and what does that look like from a federal perspective. So the federal government perspective. So again, I'm Doug, this is Bridget. We live together, we're married. And we should start off by saying any of the views or opinions expressed today are those of myself and Bridget, do not necessarily reflect the views of NOAA, the Department of Commerce, and the Department of Treasury. You're required to say that. So, applying your STEM degree, a federal perspective. So a couple quick bullets about each of us. My title is a management and program analyst. It sounds very dry. I'll talk about that a little bit more. And Bridget's is a policy specialist or analyst? Analyst. I work within NOAA. Bridget works within the Treasury. Talk about those positions when we get to it. Our technical background, we have about over 10 years in oceanographic research. That makes sense. Our graduate degrees were in marine science, but our foundations are the same, and I think the same as many of you. We have undergraduate degrees in biology. So hopefully what we've done with this presentation of not make it so focused on marine science, but hopefully STEM more generally, science more generally. But biology does have that through line. So hopefully you can take parallels from what we talk about. All right, so our goal, expand your view of what government careers can look like for scientists. You can certainly be a biologist in the government, but there's plenty of other roles that scientists can perform and are very valuable to have. And so that's kind of our operating thesis that we originally came up with, a broad ecosystem. So the ecosystem is the federal government, the public, academic institutions, non-government institutions, industry, this big ecosystem that relies on and contributes to the application of science, and the importance to have trained scientists operating throughout the system in various roles. So, Bridget.
Sure. So this is just a quote from Dr. Sagan describing the scientific approach. And, we're going to keep saying science because we are both scientists, but, we think that this can be illustrative of anyone with a STEM degree because we all have a similar probably approach to problem solving and technical skills. So, as Doug has mentioned, we like our presentation to illustrate kind of how the scientific approach can fit into careers and positions that might fall outside of the technical STEM, career path that you might visualize. And so this quote from Dr. Sagan acknowledges that, what we do with science, it's not perfect, it's a tool, But, kind of the end result of science is to generate new knowledge and in service of the public good. And so this quote kind of stuck out for me because as a government employee, I took an oath on day one to the Constitution. And as part of that is really to serve as, as a public servant, using all my skills and abilities for the public good, much in the same manner as, kind of the end goal of the scientific approach. So again, we'll just be trying to kind of draw parallels like this throughout our presentation. And I think, Doug's going to really walk through his, from grad school, early career to where he is now in much more detail in a moment. But I'll say that as I entered my first position outside of academia, so after my graduate degree, it was a policy fellowship. And so thinking, kind of challenged me to think about how I consider science fitting into policy and, how do you take the nuances and the details that go into, coming up with a scientific conclusion and put that into a policy realm where you need some kind of course of action or recommendation. And I think my very simplistic view entering this field was that there's science with all the nuance and the complexity, and then everyone else just wants a really simple answer. And if it's wrong, well, they can just walk off a cliff. And so I hope through this presentation, we'll kind of help you see a little bit of how our own experiences kind of we've shifted, or at least I can say I've shifted in my view of where we fit in through just experience and application.
All right, so a little bit of government job 101. So if you've taken a civics class, we have 3 branches of government. We have the judicial branch, legislative branch, and the executive branch. So the legislative branch gives the executive branch basically authority to do their mission, their work, and also gives them the money and the annual budget to do that work. When we talk about big government, they're not essentially wrong. The executive branch has 2.1 million civilian workers. A reference point is Walmart. Walmart has 1.6 million civilian workers, I believe was the stat. So it is quite large. So within the executive branch, this is when we're going to talk about a government job. You can work in Congress, you can work in the judicial branch, but typically when we think of government jobs, this is what we reference with these departments and agencies within the executive branch. So within the executive branch, the biggest kind of organization that you have is basically cabinet level secretary positions, and within those secretary positions are departments. So we have Department of Human Health and Services, Department of Commerce, where I sit, and then we have a whole heap of other ones: Interior, Energy, Defense, Transportation, EPA. Not technically a department, but it does have a secretary at the cabinet level. Administrator, thanks. So within these departments, we have agencies. So you're probably very familiar from seeing NIH, CDC, and FDA in the news. And then within the Department of Commerce, NOAA sits there. So you have these agencies. Within these agencies, they can be labs, offices, other programs. So I think you'll probably see agency most common when government is in the news. But there's even more resolution below that. And so a government job. So what I did was I went to USA Jobs and I searched NIH jobs and NOAA jobs, and I wrote down what I saw. So the jobs in yellow, kind of the technical positions that I would say basically carries your STEM degree forward somewhat linearly. So real jobs, health science policy analysts, clinical laboratory scientists, there's your biologists, so on and so forth. For NOAA, those positions, technical positions are, just aligned with the work that they carry out. Cartographers, meteorologists, the weather service is in NOAA. The National Marine Fisheries, so the fisheries service is in NOAA. So you have fish biologists there, natural resource specialists. But what Bridget and I are falls within this gray area. And that is kind of generic, I would say, administrative positions that kind of exist throughout the government. So you're always going to have these positions, regardless of whatever agency you're a part of. And those are program manager, somebody who does communications. You can be a specialist, you can be a manager. Director positions, your number 2 as your deputy director. And then all these analyst positions as well. So we'll talk about that a little bit later on. So that just kind of gives, when we say government job, this is kind of the workforce structure that we talk about. All right.
All right, so because this is a career talk, and I have a sense that many of you on the seminar are probably undergraduates or maybe early in your graduate career, I thought about, how common is it to fit in that gray area? You're someone pursuing a STEM degree, what does your next step look like? How do you kind of fit into the bigger workforce? And so I referred to the census and some of their latest information. And so in 2019, 2020, about half of all STEM jobs are in computer occupations, which probably shouldn't surprise me, but and then another 29% are in the engineering field. So it's a huge chunk of STEM careers in 2 big buckets. And so what that means is that the vast majority of us who graduate with some kind of STEM degree will end up in a position that is outside of, our STEM field of, expertise. So latest data available, it's something like 62% of college educated workers who majored in a STEM field were employed in a non-STEM field. And that includes like some of the positions that Doug just listed: policy analyst, program analyst, management, administrator. And then there's another 10% that exists in a STEM adjacent, the healthcare field. So kind of breaking this down, if we look at not just STEM, but look at, kind of individual degrees. Doug and I, our degrees, and maybe many of you in biology, this bucket of biology, environmental, and agricultural sciences. And it's about approximately 16% of us with those backgrounds are currently working in a STEM field. So if you, as you enter your career path, you find yourself, not finding necessarily positions within STEM, you are in great company, and there are still plenty of ways to apply, the skills and the expertise that you're working so hard to acquire at this point. So I hope that we can kind of normalize that experience a little bit for you, and kind of show you a little bit through our own, our own backgrounds and experience, how we're still able to kind of tap into that science and background. So shifting, yeah, you can go ahead. So those were, kind of STEM writ large. I didn't really break it down by whether you were an undergraduate in STEM or a graduate. So this kind of zooms in more on folks who, move on from undergraduate and into some form of graduate school. And again, returning to my friend, the Census Bureau, about 40% of STEM workers do go on and have graduate degrees. So I would imagine if you're not already in your master's degree, you're probably considering a graduate degree at some point. And this is just kind of a breakdown of over time. We can see that the total number of PhDs have increased over time. And you see that in the science and engineering fields, because that's all this NSF survey is limiting it to, those are kind of tracking as well. So these are increasing over time. Where do all these PhDs go? And so again, looking for kind of a similar time range as for the information I just described about overall STEM. What happens when you graduate with your PhD? Most folks enter some kind of postdoc position. So greater than 50% of people will enter a postdoc. And then ultimately, when they're employed, the majority or the largest percentage falls into the academic sector. So, Doug and I are definitely in the minority in the, our first kind of post-grad commitment was in that other category. We both took a fellowship, a policy fellowship here in DC, and now we fall into that, 12% or so of folks with PhDs in the life sciences that work currently in the government. So I can say that when I begin this path from undergraduate to, a postgrad, which I'm saying is inclusive of fellowships, postdocs, entry-level positions, I'm certainly not making this a pitch for you must go to grad school. And then my early career, I definitely envisioned this as a very linear path as far as I'll have my educational base, I'll move into some kind of entry level or additional training, and then bam, I'm straight into my early career and I will progress from there. And I can say that, for a variety of reasons, that's not exactly how it worked out. And it was very iterative. I would go a little forward and then, I wouldn't say go back. I don't really like that terminology, but, when move forward, I had a full-time position that it could have stayed on, but I realized that I wanted to kind of transition fields. And so I took a fellowship opportunity to get more training. And I also want to just kind of point out, because you guys are all experiencing the world in the time of COVID, and I know that that must be impacting careers and what your next steps might look like. Doug and I are both elder millennials. And so when we first, were thinking of entering the workforce, there really weren't a lot of jobs out here. As you can see, the Bureau of Labor Statistics show this, just dearth of opportunity to enter the job field as we were graduating from our undergraduate degrees. And so that helped kind of inform what our next steps would be. So, sometimes there's what you want to do, and then there's also all these external factors that, come into play and help sort of shape your path going forward. And we're very much products of that. And so, if you're facing that right now with COVID, we promise there's sunnier days ahead.
Yeah, so when we were going through our fellowships after our graduate degrees, I did a lot of kind of informational interviews and talking with folks. And my most common question was, how did you get to where you are? I would find somebody with a job I thought was interesting and something I could probably do, and then ask them how they got to where they were. And the slide that Bridget just showed is a really good example of you need to have multiple data points, a lot of data points, because our experience is different. I would talk to a lot of people at the end of their career, and it was like, all right, well, everything that you're saying sounds good, but it's not really what I'm facing at the moment. So instead of this linear path, I came up with kind of stages or phases that I think I experienced going through the past 17 years or so. So I don't mind dating myself. I started undergrad in 2004, and 2004 started undergrad. That your undergrad, you should be establishing a foundation. And I did that with a degree in ecology and evolution biology. There was a brief stint as a mechanical engineer, so there was a little bit of exploration. But then I was ready to graduate at the end. And I didn't feel I was ready for graduate school. I definitely wanted to apply and just work for a little bit. So I did that. I worked as an oceanographic research technician. I worked in Bermuda for 4 years. And through that, I just, enjoyed working, thought a little bit about what I wanted to do. And then at that point, I realized I wanted to commit and focus on something. I realized I wanted to kind of manage my own science. And so I decided to pursue a PhD in marine science at the University of South Carolina. I was able to kind of find a spot for me in graduate school through the networking I did as an oceanographic research technician. I met quite a few people and had a good lay of the land. So I wasn't going into it relatively blind. And that was really nice for me not to go into blind. I think I was successful in my graduate career because I had a lot of work experience. So during my PhD, there was one thing, I had kind of two goals, really hone the technical training of what it is to be a scientist, like that complete scientific process. I did a lot of things on my own, instrument development, method development, some field work, lab work. So really wanted to build a really strong foundation, then also develop a technical expertise. So as I'm going through graduate school, reaching the end, 1, 2, and 3, that's what, 13 years? That's 13 years. And so what I realized at the end of that graduate career was reflecting on what I was doing and kind of redirecting myself. And I was, an academic pathway was probably something that changed how I envisioned it. So I was curious to explore a non-academic career. And then Bridget and I were fortunate enough to get fellowships in DC. Moved to DC. I took 2 government fellowships. The first was 1 year with NOAA, and then I did another partial year with EPA. That EPA fellowship would have been a little bit longer, but I got offered a job, and I took that. Throughout that fellowship time, so a year and a half or so, yeah, my goal was really to diversify my skills, myself. I didn't want to be too narrowed, and then just more broadly grow with soft skills, some technical skills as well. During this time, I really wanted to understand organizational management, like how does science get done? I worked at a couple institutions that just didn't really function all that well, and I wanted to understand just how are decisions made. And I wanted to understand the regulatory process as well, and I did that at EPA. And I wanted to have career options too, so that was a big part of that. And then at the end of this, phases that you can, I think, move these around here and there. But after end of this long period, you can reflect and maybe coalesce everything you've done. And that coalescing was this broad understanding of a science enterprise, and so that's what I'm doing now with my career, and I'll talk about that in a second. But first, I want to give an example of a job where you're really using that technical training that you got. And I wasn't necessarily using my graduate school. I was even using, just the basic undergrad degree as well. So let's talk about my fellowship with EPA, the Office of Water. I want to get that away.
Yeah.
We'll worry about that. Okay, so ORISE. ORISE is a big fellowship program. It's run out of Oak Ridge Institute of Science.
Yeah.
I forget exactly the acronym. I looked it up and then I've now forgotten it. But it offers a really wide range of fellowships for current undergrads, post undergrads, graduate students, master's and PhD, post PhD, and it addresses a lot of different STEM fields. So agencies participate in that program. DOE, I have a friend that did a postdoc with CDC. EPA has one, and they're really good positions. They're interesting work. A lot of times they take that fellow and give them a job afterwards. So I recommend looking up ORISE if you're curious about government policy, and they're available throughout the country as well, and they're well managed, and you can kind of consistently see new openings and they get filled. I know when you go to job sites, it's like this black box, and ORISE I think operates pretty well. So while I was at EPA in the Office of Water, I worked in the standards program, so water quality standards. And the job that I held, if I was to have a real federal position, would be an environmental protection specialist. That role specifically was a coordinator with Region 6. EPA is broken out into regions. See it on this map here. I served the South Central. So my responsibilities was to engage with regional staff. So there's regional staff, in EPA. I was at headquarters. I worked with contractors, people within state environmental protection agencies, experts across other parts of EPA, and we would review and analyze potential changes to a state water quality standard. The perspective we had at EPA, or in this program at least, it was to implement the Clean Water Act. So remember that one of the first slides with the government jobs, you have legislation, they're developing the Clean Water Act, and within that legislation, they make statements, EPA has to have this program that does X, Y, Z. And so that is our mission. And what we try to encourage is water quality standards that are backed by science, that are protective of water bodies. So we encourage states to have their own water quality standards. Real quick, I'll see if I can explain the water quality standard in like two sentences. Water bodies, a river, a stream, an estuary, a lake, yeah. They have what you can apply as a designated use, and that use can be fishing, it can be swimming, it can be drinking water, and that use will have a standard associated with it, well, a criteria associated with it, that some part of water quality needs to be below a threshold that science deems inhospitable to basically the aquatic life, or whatever use that it is. So that's basically what I mean by water quality standard. And it's simply a written regulatory rule. So I want to give an actual example of actual work that we performed. So here's a little story. Wastewater treatment plant in one of these Region 6 states was having an issue with copper in their discharge. So copper at certain levels is toxic to humans, to aquatic life. And this wastewater treatment plant has a permit that they need to be below X amount, some concentration of copper, and they're required to measure that X amount of times over a certain month. That permit was built on an old standard or model that EPA published. We'll say, okay, we have more science on this model, let's update it. So I think they were using something from the 70s, and 2010-ish, there was a new model for copper. So they were testing inputs of that model. And it turns out that the inputs that they found when they put it in the model, it was actually lowering the standard for water quality of copper for this receiving water body. So EPA, the regional EPA gets this request to lower the standard. We review it. And this is something I reviewed pretty independently, and then provided rationalization that lowering would not be protective of some of the aquatic life in the area. So kind of, yeah, it's a desk job, but you're definitely using all that scientific training that you've gotten, and you're really, applying it to real world situations. So from EPA, I got a job back with NOAA where I did my fellowship. This is within Sea Grant. And again, I'm putting my new mission, utilize broad understanding of science enterprise. So I hold the title of a management and program analyst. NOAA Sea Grant, our mission, we were set up by this congressional act, right? So there's our authority, established in 1966. Our mission is to enhance the practical use and conservation of coastal, marine, and Great Lake resources in order to create a sustainable economy and environment. That sustainable economy is a big thing for us because we are in the Department of Commerce. So Sea Grant has 34 university programs. We provided about $90 million in funding to those 34 programs. Our strategy is each of these state institutions, Illinois, Indiana should be listed here.
I think the marker's just off a little bit.
No, there should be the orange is extension agents,
Okay.
but there should be a NOAA bird right here. It's located at Purdue. So the model for Sea Grant is it's kind of stakeholder driven coastal science application. So we have what we call outreach or extension agents. They are placed throughout the community, different parts of the state. They understand from coastal science stakeholders, ports, coastal management folk, water quality folk, what the needs are. And then we take those needs and do research on that. And then we actually, we have an educational function as well, where we do K through 12 and then also professional development as well. Bridget worked for South Carolina Sea Grant. So what do I do here? Really generic title, but I get to have a decent range of duties and impact. So the first is I manage programmatic data. So we get a ton of data from these projects, and we have a data repository, and we basically use that data for a lot of different purposes for communication to Congress. So very often I reply to somebody within NOAA that says, hey, somebody in Congress has this question. Where do you spend X amount of money? What have you done? And I say, this is what we've done. We use it for operational insights and strategic planning. So I like that aspect of kind of like how to shape our work. Related to that, I do a lot of work with designing our operational practices. So basically how an organization conducts its core functions. Again, with the data stuff, I've been leading a software development project, basically increase the efficiency and of government work. So sometimes that's
it's very necessary.
It's very necessary. Yeah, it's very necessary. And these are really positions and projects that you get to use all your soft skills. But the technical background also understands that broader picture of how everything should work together and what really matters. How is somebody else approaching kind of this dynamic? And I'll show kind of a systems approach at the end. And then still in this position, I get to utilize my technical background. For about a year, I was a federal contact for an aerospace company out of California. They were using their communications technology and basically their engineering skills to develop a water quality monitoring platform. They didn't know the space, but I was there to kind of introduce them to people, make sure they could get with the right folks to test their instruments. And since it was water quality, I knew the instruments pretty well that they were trying to use. So that was great to use that background. It came really handily. And I'm now also being asked to, kind of help think about where to direct money. Congress is looking at Sea Grant and other parts of NOAA to do, kind of new initiatives. One is in marine debris. So that's something we're actively looking at right now. So quite a range of things I get to do. So I talked for a little while and I pass it back over to Bridget.
Okay. Thanks, Doug. And hopefully I can kind of build off some of the points you made and bring it home or bring it back to sort of my perspective. So at the start, Margaret introduced me as working in the Department of the Treasury, and maybe your eyebrows raised and said, a scientist in Treasury who's not an economist. That's kind of interesting, but I work for a fairly unique program. I wouldn't even say fairly unique, a very unique program within Treasury. That's a result of one of the largest natural disaster, or excuse me, not natural disasters, largest disasters in US history, which occurred back in 2010. I'm originally from the Gulf Coast, so I remember this day and the months that followed. On April 20th, 2010, the Deepwater Horizon oil rig essentially exploded. And unfortunately, there was a loss of life on that day. And then for months following, there was the largest offshore oil spill because this was a deep water rig. It was very hard to cap the spill site. And so oil flowed, I believe, until September of 2010. So because this, natural disaster impacted the entire Gulf Coast, Congress stepped in and wrote a piece of legislation that I'll refer to as the Restore Act that was signed into law in 2012. Excuse me. And that basically directed, what would happen with the penalties that, excuse me, the BP and their partners were required to pay as a result of civil litigation. They violated, as Doug mentioned earlier, the Clean Water Act when this spill occurred. And so this created a whole new program that was, thanks to Congress, put into the Department of the Treasury. And that is the office I work in today. I'm so sorry. So just very briefly, I don't want to go too deeply into this, but it is kind of interesting how, Doug started at the top kind of saying, here's Congress, here's the executive branch. Congress writes, a piece of legislation, the president signs it, and then it goes over to the executive branch to actually be implemented. So Congress says, hey, do all of this. And it's like, great. How do we do all of that? So, I think our office is definitely still a work in progress. This is relatively new legislation. And, we developed our regulations that were finalized in 2015. And our program has, existed and has been running grants since 2015, 2016. And so we talk about it in terms of buckets. This money, goes from the Clean Water Act penalties, 80% goes into this trust fund. So it's not taxpayer dollars, it's BP settlement money. And the two buckets on either side, bucket 1 and bucket 5, are the programs that the Treasury Department is responsible for. So bucket 1, that's a direct component. So money goes in here and is distributed amongst the 5 Gulf Coast states. There's a variety of projects that they can undertake, including restoration projects, workforce development. They can upgrade their state parks with this money. It's all to go back into the economy and into the environment that was damaged by the spill. And then on the other end, bucket 5, which is really an area I get to work in, is the Centers of Excellence, and that's for science, technology, and monitoring. So each of the 5 Gulf Coast states has money from the trust fund. They establish these Centers of Excellence, and then they conduct research. And so I guess what I'd like to highlight at this point, and kind of going back to something that we sort of started at the top of this, is there's this, ecosystem that generates science and relies on science. And so how does my current role kind of fit into that? And there are very clear roles and responsibilities and duties that I perform, first as a program analyst and now as a policy analyst. I work with the state partners, I collaborate with federal partners, I provide technical assistance to my grantees. I just manage grants. I'm in grant solutions managing grants. So sort of on the opposite side of many of your professors. I evaluate operational alternatives, all this kind of stuff that's very, again, a lot of different people with different degree backgrounds could carry out these roles and responsibilities. But because I'm a scientist and I bring my science background to my current position, there's also an opportunity to use those skills. And so even above and beyond what was on the paper when I applied for this position, there are activities I'm now able, that I now carry out because of my background. And so these include things like updating our best available science and policies and practices that our grantees are required to evaluate when they conduct a restoration project. I develop measures for the real world impacts of Restore Act, specifically for our research program. So how is the research that we're funding actually being applied and used in the Gulf Coast region? I get to use my data skills and develop data-driven efficiencies to our office policies and procedures. finding efforts to be a green pen when it comes to, granting. Investigating innovative approaches to long-term research investments. I know, again, that might sound kind of dry, but it's, the sort of the meat and potatoes of, the research industry. So how can we, for example, in the state of Alabama, they have several offshore monitoring platforms. They're really interested in using their restore funding to keep those going, in perpetuity, because this is a relatively large pot of money that they can use. So how do we get innovative and make sure that that is something eligible under restores, requirements, and something that they can actually do that is good for the science in the area, and works long term. And then I still, as many of you will probably do in your future careers, I certainly serve as a science translator. And right now, under our current administration, we're really shifting to talking much more openly about climate change, climate risk, and those related topics. And so, because I'm a scientist, and I, so my research kind of touched on that background, now I'm a de facto expert in our office because of that. And I actually developed with our state partners our first climate change website. So, my point here really is that many people can do these types of jobs, but you as a scientist or someone with a STEM degree will bring unique expertise and unique skill sets, and there's often opportunities to apply those. So if you look at a job description and you say, I don't know if I exactly see myself in this position, but I'm intrigued or I'm interested, just think about how your skill set and expertise may be able to translate even to positions outside of, maybe your comfort realm. And I'll turn it back to Doug.
Yeah, okay, so we promised this at the start of describing this broad ecosystem. So I'm going to try to do it, reflect and synthesize a bunch of different pieces that we've talked about. So bunch of different actors here in light blue. We have private interests, might be industry, might be, public interest here, non-government organizations. We have Congress in gray. Congress has, congressional committees. They're the ones that may be badgering Trump witnesses and things like that. And then you have appropriation committees, and those committees hand out the money. So again, Congress gives policy and authority to government agencies. They also supply them with the money to implement the policies from Congress. And that is like the Clean Water Act or the Restore Act that we've mentioned. So within that, we have to prioritize these investments. You want to do everything, but it's very hard to do everything. You're still hamstrung in a lot of different ways. And within an agency, you have, a lot of different functions, but to me, this is what I think about. So you have, scientific R&D, you have coordinators that may work across multiple parts of the agency or between agencies that are trying to connect who's doing what. You have communication folks that are talking between Congress, between the public, and across agencies as well. And then there's collaboration, cross-agency. It's a little bit more, partnership than just kind of coordinating efforts. 3 or 4 entities, working, and this is probably actually more like scientific R&D, but it's a big component of it too. So moving on, this ecosystem in orange, we have the academic enterprise. And so a lot of the times this is with Sea Grants, so this is government funded science. We have these investments that should be implementing the R&D process. And you might have research and development, you have education and training, and then you might have advisory services that faculty provide, whether their own specific lab does this and does outreach, or specific advisory functions of academic institute. And within each of these agency functions, you'll work with, in a lot of cases, folks in different parts. You want to coordinate, who's doing what and just where is their expertise. Wanting to understand all the stakeholder interest of what they're interested in, what would be useful to them. And so ideally these investments start up with Congress awarding money to an agency, turn into, application tools or better inform future policy. And that policy can be whatever, health, environmental, tech, you name it. And within this, there is also an evaluation period too, that Congress wants to check in on how the agency is doing. We evaluate ourselves and we evaluate those performing the research. So one thing I like about government work is it's very complex, which means it's interesting to problem solve. One thing I hate about government work is it's very hard to do things because you can see how complicated and complex a lot of these relationships are. And so when we say it's important to have trained scientists operating throughout the system, we have to remember with a system like this is you actually have individual people operating through this, right? And in the government, I should say, the executive branch, it's very useful to have scientifically trained people throughout here. I should say that should be the case definitely in Congress as well. And there will be people in the public that are trained as well. So I should be spreading out these orange circles a little bit more. But that's what we mean by this broad ecosystem. And you can, regardless of where you end up with your STEM degree, you can still help influence science and the application of that for good purposes. So with that, Bridget.
I hope our handoffs aren't too awkward, but yeah, so kind of returning to that, the challenge I set for myself kind of entering the field of policy from academia is sort of where does science fit in? And rather being this binary choice, there's science and all of its glorious complexity, and then there's the simple answers everyone wants. I think, again, we're still fairly new in our career, but I think there's an opportunity for science and, there's the big science and the scientific process and, standing on the shoulders of, giants and the piles of research that's out there. And then there's just you as an individual, with your training and your skills. And in both of those ways, I think that science is very much a part of everything else. And that answers, you as a person with your training can kind of serve as a bridge between this, between the scientists on this lonely road and the rest of the public, and that there's many opportunities to do this. This is our perspective, and your path will be different, but there's ways to feel like a scientist, even in positions that might, lie outside of your field of expertise.
So we have some tips.
And we can even leave this here. I'm not sure where we are on time. Yeah, we could just leave this kind of up here and, just start taking questions. Our next slide is just a really pretty picture of the Capitol that I did take. So we can just leave this here and we're happy to answer any questions. And Doug mentioned the ORISE fellowship. We have a few other fellowships. We're always happy to have unpaid interns, but I'm sure you are all far too qualified to take a position like that. But we'll be happy to send along any resources for, career advancement.
Okay, well, huge thanks, y'all. Give hand claps or reactions or emoticons or however else you choose to show gratitude. I will do verbal and all of the above. Thanks, everybody. So feel free to pop questions in the chat and I'm happy to read them, or if anybody wants to open it up to unmute yourself, you are welcome to go ahead. While people are pondering what they're gonna say, thoughts on favorite aspects versus least favorite aspects. Doug, you said the complexity keeps you stimulated and moving, but it's also a challenge in terms of actually getting things done. Bridget, what's your take on that?
Yes. Double down on that. I think sometimes, especially because I wasn't as familiar with working so closely with lawyers, obviously in my academic science training. And so there's always that kind of level of like, okay, this may make a lot of sense, but will a lawyer say that we can do it? Because the law is, up to interpretation, and that can really vary depending on who's reading it and what their interest is, which can sometimes be a little frustrating. Not to bash lawyers, of course, not at all. Very necessary.
A question popped into the chat. Do you know anything about how physics is employed in these fields? Where the government might employ atmospheric or oceanic physics or geophysics? Physicists, excuse me.
Yeah. So I think you can still see the slide since we're just sharing the slide. The modeling. So anything, physical oceanography, I know you do a lot of coding, ocean modeling. Those modeling skills will find many probably opportunities as maybe a data scientist, specific modeling positions. You see that more and more. But that core skill that you get out of where I would say physics is, R, MATLAB, Python.
And NOAA. NOAA is a really, as far as agencies to look at, I would say NOAA would be my top choice. And then also the USGS, I'm not sure, it's more atmospheric and oceanic rather than just a hydrologist. But NOAA absolutely has physical scientists. And one thing to consider, neither Doug and I, we're both currently feds now in full-term, career positions, but we started as, each of us is sort of an ORISE or almost like a contractor. And so the government, another thing to look at is NOAA employs, has contracts with several different, environmental consulting groups. And so there might be environmental or, geophysicist positions that are contractors as sort of your foot in the door, or some people stay with contracting throughout their career. That wouldn't be posted on USA Jobs. It would be posted on NOAA's contracting website. So we could probably send you there's a few sites that we could include that would point you that direction.
And Naomi, a good thing to do is USA Jobs. There's a lot of bad job sites out there, and I would say USA Jobs is one of the better ones. They did a good job of rebranding it, and it's a pretty powerful search function. So you can look up just physics. That might get a hit. You could look up physicists, and then physical scientists. Physical scientists could be, geologists, things like that. It's a little bit broader. One of these points is really strongly recommending to Google your heart out. And when I was looking at opportunities, I was Googling a lot, looking at people's, I would go to about sections or who these people are with different organizations, be like, who are you? What have you done? What's your education in? And then I would kind of backtracking that to see what type of jobs there are, and then what type of responsibilities and skills are needed for those jobs. So start by Googling a lot, and then once you kind of find up some good sites, hone the physics aspect of it, and then start to see, looking back and forward, what could you do? And then what else can you complement with the physics, or what else within that physics degree is what really they're looking at. And my guess is in a lot of cases that computing and math knowledge is what they're after. And that's also my point of build a foundation, that math coding is your foundation.
Very transferable.
Yeah.
You have on that slide a couple asterisk points next to job boards. Was that indicating that some of them are not so great, but that USA Jobs is one of the better ones?
Let's check our notes.
That's
Check
no.
my notes.
Check our notes here. What
got
do
that
we
one?
mean? I don't know what our asterisks meant there. I'm not seeing them.
Was it significant? P less than 0.01?
Who knows? I would say it's like super important.
Yeah,
That's probably my Googling tip.
right.
I have a question if I could. So I think before the talk, we talked a little bit about diving. I want to kind of segue that into this discussion. Within the government sector, is there any opportunity for kind of any ocean science jobs that almost like require someone with a scientific diving background or a diving background?
Yeah, definitely. You know, NOAA does a lot of that through government contractors. So they might have this exists in the government works with contractors a lot. So there's these contracting agencies. NOAA will say, hey, we want to work with this contracting agency, and they provide the jobs, and they'll go attract people that do kind of a lot of technical work. And so there will be
yeah, there are literally
like
I've seen job titles of like dive specialist.
dive specialist.
Yeah. So short answer, yes. Again, the easy answer is NOAA. I think EPA probably there's oceanographers for the EPA as well, more on their regulatory programs.
There's
Trying to think of others.
mapping programs that might be benthic mapping, that rely on scientific divers.
Yeah, I'm trying to, maybe USGS even has some, or Army Corps, the Army Corps of
Army Corps,
Engineers. I wouldn't be
I
surprised.
bet
if they
the
have
like military divers are probably
yeah.
suited for Army Corps. Does that help?
Short answer, yes.
Yes, there are. And again, at USA Jobs, if there's specific government ones, these are federal positions, and so you won't find contracting jobs.
Yeah,
on
but
US.
we can send a site for NOAA's top contractors. They list it by kind of area of specialty or line office, and they have you can go straight to the contractor website and then search by NOAA or by the kind of job description that you're talking about. But it is independent of USA Jobs.
Indeed is a good, basically huge search engine for jobs. So if you did like NOAA diver, it might bring up contracting companies that have that position. But then this is a good example to use your network, and you might not think I'm in your network, but you just heard me speak. You know my sister, so there you go. Like that, utilizing your network to that degree, right? Even if it's like 2 to 3 degrees of separation.
Well, thank you so much.
Yeah. Oh, sorry.
Yeah.
I was saying we got another question in the chat about a citizenship requirement for working for the federal government.
That varies typically by job series, and sometimes by the agency itself. But here, let me just say, when you go into USA Jobs, or if you're looking at a contracting site, it will very explicitly say if there are citizenship requirements. So you can easily rule it in or out. The position, I believe ORISE also, right?
Yeah,
believe
they'll
ORISE
specify it. I don't know
yeah.
if ORISE allows.
I think
foreign
it again
citizens.
depends. I think it depends on the office, and whatever, I hate to say it, but it's probably some kind of security requirement. But it wouldn't be left a mystery. You would read the job description and they would state in the first paragraph or so whether it's open to non-citizens.
Sea Grant has a fellowship. This is a fellowship that we did, and we allow foreign citizens to participate in the fellowship,
not in all positions.
but not in all positions.
So
exactly.
State Department, for example, for that particular fellowship, you had to be an American citizen for. So yes and no, depending.
So how Was this helpful? Did this like kind of expand your knowledge of STEM careers and government in general? Yeah, people
I would
nodding,
say it
right?
seems to be the case. We're getting lots of questions. So we just
Okay,
got
good.
one more from another grad student in the chat. Are there positions in the federal government that work collaboratively on these kinds of topics with other countries on an international level, specifically within marine biology?
Yeah, in NOAA, I think this is I don't know if it's the case in every single. So in NOAA, we have line offices. It's another kind of broken down bureaucracy. We have an Office of International Affairs. So I think it's maybe 10 people large. It has maybe 5 federal staff, 5 contractors, and they work with different parts of the country. So we have different, initiatives with.
Well, and then I would say within NOAA, you would also have within marine fish, within the just within the fisheries line office, there's a lot of international coordination because, fish like to travel across international borders and stuff. So yes, same at EPA. I know that there's, a lot of depending on what region of the country you're in, if you're at the southern border or northern border, there's collaboration that has to occur. And regulations in the Great Lakes, honestly, is a great example of where federal agencies have to coordinate with Canada regarding shipping and the contaminants that ships can bring in, and how the circulation of the Great Lakes would obviously also be in Canada's jurisdiction. With the St. Lawrence is probably mostly Canada. So sorry, long story short, yes, there's plenty of offices. If you looked, I'm trying to think how best to kind of identify those positions, but in USA Jobs, you could look for, honestly, the keyword international might bring up positions. I'm trying to think.
They would probably be called program analysts.
Yeah, right. But it'd be within the, an international office.
They definitely exist. They're pretty sought after.
Mm-hmm.
We have a position with our fellowship program on an annual basis. We have about 70 fellows that come through, and we place people with either in NOAA or different agencies. We usually work with about 15 other agencies, and I think out of the 70, like 20 or so people want to interview with the international affairs folks. You get to try. You could have traveled.
Yeah.
Hopefully some point soon they'll be able to travel again. But that's why it's
pretty popular.
Pretty popular, especially for recent grads.
I know with Restore Act, we're some of the research. So for our research program, the lead PIs for the research projects need to be based in the Gulf Coast, but they can collaborate with individuals in DePaul University or elsewhere within the US, and also international collaborators. So I know that some of our research that we're funding, because Gulf of Mexico, obviously there are there's Mexico and there's other countries that are part of that region. There are that's a very small scale on an individual research project level, but I know that we do support some research that has an international component.
We'll keep talking as long as you guys want to listen to us, by the way. But I know it's 4 o'clock on a Friday. And
well, it's 3 o'clock on a Friday.
Yeah, right. So we recognize, but we're glad to keep talking.
Or, if there's resources that we could pull together and send you to distribute, we're happy to do that as well. We'll definitely send you the contractor sites for NOAA.
That would be great. Yeah, I already got your fellowship links and posted them to all of our general biology pages for the quarter. So.
Awesome.
Does anyone else have any questions for Doug or Bridget?
No, the cats. I'm just kidding.
They are, honestly, they are right behind us. I'm not sure if you can. There they are.
Oh,
they're just
thank yous.
Sleepy little blot. What? One of them's waking up to say hello.
Well, thank you again. This was a really insightful presentation. I think we all learned a lot, and my exposure to government science is really limited too. So it's great to see how many opportunities are out there, and I appreciate you sharing all those resources with our students too.
Yeah, thanks, Caroline. I mean, it was a whole new world to us too, different language, things like that. And it's good to understand how the world works, right?
And different,
Mhm.
yeah. Feel free to connect to us on LinkedIn. We're both there under, our names as they are on the presentation.
Thank you again.
Thanks, everybody.